All right, so here's another example of the Huntington Hill method. And look, it's those same three companies from before, Naxon, Erico, and Eurobio. But I'm going to show you a little trick with Huntington Hill. Since all three of those numbers go out to the thousands, you can actually, is there a black highlighter? There is a black highlighter. You can actually just knock off these zeros. Well, that didn't work too well. Try that again. You can just knock off these zeros and just use 47, 37, and 16. As long as you're consistent and you divide off, I'm basically dividing by 100, it will not change the comparison value of your Huntington Hill numbers. Now, if you want to leave it as 4,700 and square it, you can, but you're going to get a really big number because 40, my calculator might, 4,700 squared, what is that? Hang on. I just did something silly. Squared. Boop. One more time. Sorry. 40 heavens. Squared. There we go. Oh, my calculator handled it. Oh Lord, that is 22,900,000 or 90,000. It'll still work. You'll just have really big numbers. So, if you can, simplify your numbers. You'll use less buttons on your calculator. So, okay. Assume that the Oil Consortium Board currently has 2 members from Naxon, 2 from Erico, and 1 from Eurobio, which may have been the result when we did the Hamilton method. I can't remember, but let's just say that's what they already have. And they decide, okay, we need 1 more board member. So use the Huntington Hill apportionment principle to decide which company should receive the next member on the board. Now they already have 2 and 2 and 1. So when you take, and I did these in different colors, you can see on this one, it's 42 squared divided by, they already have 2 seats. So it's going to be 2 times 3. Erico, there's their population, 37 squared. They also have 2 seats, so it's 2 times 3. And then Eurobio, 16 squared, but they only had 1 seat. So they're 1 times 2. Remember, it's always the next number up. So 2 times 3, 2 times 3, 1 times 2. And I'm going to compare those numbers. And of those 3 numbers, this one is the large. Excuse me, since 368 is the largest, Naxon should get the next representative. So, couple of things to know. Number 1, when you use Huntington Hill numbers, it satisfies 2 important criteria. Number 1, this method actually prevents the Alabama paradox from happening. And 2, assignments can be made so that the relative unfairness between any 2 companies is minimal. That's what this method does. It's a much better method than the Hamilton method. But anyway, let's see. What if we wanted to start from scratch and assign a certain number of seats at the same time? Let's use those same 3 companies again and recall from the form of the Huntington Hill number written in terms of representatives to the Oil Consortium Board. So it's the number of stockholders squared over the current representation times that same current representation plus 1 more. That's how it's applied here. I usually just say it's the population squared over the number of reps times the number of reps plus 1. And in this case, your population is stockholders. Okay, so what you do is you start with everybody getting 1 seat on the board, because that's fair. I mean, there's 3 companies. They should all at least get 1 seat on the board. Makes sense. So you start with, and I will grab another highlighter here. How about pink? So all of them have 1 times 2, 1 times 2, 1 times 2 times in their denominators. And again, it's 47 squared, 37 squared, and 16 squared. So this is when you're looking at the very first seat, right? They each have one seat. You're trying to figure out who gets the second seat. And when I look at these three numbers, this one's the biggest. So they're going to get a second seat. So now when we're on to the second seat here, it says we will now add lines to the table to determine how to allocate the remaining representatives. Hang on, did they say how many representatives? Okay, well, it's not saying. They're just going to keep assigning representatives, I guess. So they created a table here. And when you look at this first row, that was the numbers that they had in that previous slide. It was 1104.5, 684.5, and 128. 1104.5, 684.5, and 128. So that was what we had from the previous slide. And you'll notice that they drew a line. They drew a line right through this one, and then they put a number 4 here. That's because Naxon gets the 4th seat. Now, when it says current representation, they each have 1 seat, right? But when you compare the Huntington Hill numbers based on that 1 seat, whoever has the largest gets a second seat. So now we're going down to, okay, who has 2 seats? Since I crossed this one out, they are going to calculate this Huntington Hill number right there, but not any of the other numbers. Now, every box is filled in. I never do that. I don't sit and do all these numbers and then cross them out as I go. I just do the numbers that I need. So I do have to do that first row, which is all in pink. And then once I figure out which one of those is going to get the next seat, I cross it out. That's that black line. And I'll put a number 4 there. And then I'm going to highlight the next thing that I do, which was in that blue color. Now what you have to do is compare this number with this number and this number, because, and I'm just going to scribble it out real quick, but I'll take it off there, because technically none of this is here yet. I haven't done any of that yet. All I had were those first 3 numbers up there in the highlighted pink row. So once I figured out that Naxon got the next seat, I cross it out and I calculate the next Huntington Hill number. And then I compare those 3. 368.2, 684.5, and 128. This is the next largest number, and you'll see there's a little 5 right there. Now once I do that, I'm like, okay, I've used that one. Cross it out and calculate this number. And then I go from there. So what they did is they went through all of that and they kept crossing things out and putting down numbers to figure out who gets what next. And they had figured out in the end that Naxon will end up with 4 seats, Erico will get 3, and Eurobile will get 2. I guess they were doing 9 seats altogether, although I don't remember where they said that. But it's kind of confusing the way this PowerPoint is showing it, so I'm going to show you how I do it, which I'll do a table like this, but I am not going to fill in all these numbers that I won't be needing until I need them. I'll have to calculate them as I go, if that makes any sense. All right, so that's the end of the PowerPoint. So my next videos will all be my MATLAB examples. And here we go.